Let's use the previously created DWIN design to display actual serial data. As shown in the figure, it is a simple task of sending data from an Android smartphone to the preview window and changing the value. Even without a DWIN monitor, you can test by sending data to the DWS preview screen via serial communication. Most laptops support Bluetooth, but for desktops, you can use a USB Bluetooth dongle. If Bluetooth is ready, pair your desktop and your smartphone in advance. Your phone must be registered as a Bluetooth device to transmit data. If you look at COM and LPT in the computer's device manager, you will see the active communication ports. We will communicate through these ports, so refer to the names. If there are multiple ports, you can try connecting to each one and select the port that communicates. These port names may vary depending on your environment. If you are using an Android smartphone, you can download and install an app for Bluetooth communication from the Google Play Store. When testing DWIN monitors, this app is useful. Go to Google Play Store and search for STEP-6, and you will find it right away. You can preview how to use it with the play button, and you can also watch it on the YouTube channel STEP-6. The following examples will be tested using this app. The test is conducted under the assumption that the desktop and smartphone are paired, and the communication app is installed. Run DWIN design you created earlier in the preview window. First, click on the Port section on the right side of the preview window, and Refresh will appear. Click on it, and a list of computer ports will appear. You may see some strange characters in the list, but you need to input them directly, specifically COM18. Next, select 9600 as the communication speed. If it is too fast, the preview may not be able to handle it and the program may stop. Now that the communication port and speed have been set the port to open. Now you are ready to communicate with your smartphone. When you run the smartphone app, you will see a list of paired devices. You will also see the desktop name. But if you do not see the name, the device has not been registered, so you will need to register the device first. The BPS speed is 9600 by default, but if you want to run at a different speed, you can change it in the main menu to match the speed in the preview window. Select the desktop device name, click the Connect button, and attempt to connect. If the connection is successful, the basic communication screen will appear automatically. If the connection fails, you will need to change the communication port in the preview window. The hexadecimal format for sending general data to widgets in DWIN monitored is as described above. Check the hexadecimal type transmission and enter the transmission code above. Once you have finished entering information, click the Send button to send it. Since I sent it as VP50, the VP50 widget content changed. Since it is a 2-byte signed number, when I entered a large value, it was displayed as a number with a minus sign. This time, let's enter a small number and run it. You can see that the values you entered are displayed correctly. You can see that the communication is working properly. However, it would be very inconvenient to input commands one by one like this. There is a way to save data in advance, select it from the list when needed, and send it with one touch. If you select the Work with List menu, you can see the saved list connected to other devices. If you select this list and press the Send button, the saved content will be sent immediately. This list can be edited, deleted, or added from the Edit List menu. By device name, the list can be used independently. Let's add one more list. First, let's set a device name. If the device names are the same, the list will be grouped by device name. You can use an existing name or create a new name. For now, let's create it as WOOTZA01. Let's title this command list VP50. Something easy to understand would be nice. Enter all the data to be transmitted. Below, you must check the hexadecimal mode for normal operation. If this is not checked, it will be transmitted as a string and will not operate properly. We will create 2 more VP addresses, so copy the contents. Save with the Save button. Add another list. Change the VP address to 5100 and save the data differently. Of course, the device name must be the same, so that this list will belong to this device as a group. In the contents, paste the copied content and modify only the VP address and data value. In the same way, add one more list. Save it by making only the VP address and data value different. Once the list is complete, select Work with List from the menu. Click on the device list and select the device. If you select the list one by one and press the Send button, you can see that the saved contents are transmitted. Depending on the VP address, each data value is changed. This list method can quickly manipulate devices such as Arduino. There is no limit to the number of devices or lists that can be registered, so it can be used in various ways. This app has another feature, a test screen dedicated to DWIN widgets and a Work with DWIN menu. First, click the Edit DWIN list menu and add a list. It's similar to the Work with List menu, but it works differently. In the list input items, the device name and title are the same, but the data input is different. There is no header string to send to the DWIN monitor. Internally, the header string is automatically sent, so you only need to enter the VP address. Also, if you enter the minimum and maximum values for the data randomly generated within that range will be sent. In the same way, a list is created by specifying only different VP addresses and data value ranges. Now that we have 3 lists, one for each VP address, to use them, from the menu, select Work with DWIN. When you select a device, you will see a list of devices related to it. Now, the visible lists will be transmitted in sequence, and below, you can adjust the time interval between each list, which can be changed in milliseconds. When you press the loop button, all the list contents will be transmitted automatically, one by one. The loop button will change its name to Stop, and it will repeat infinitely until you press the Stop button. Loop speed can be made fast, but on the preview virtual monitor, if it exceeds a certain speed, the program will stop due to the graphics processing speed. In preview, 1000 milliseconds would be good for testing.
Goodbye. See you again. Like and subscribe, please.